Hello everyone, and welcome to the first seminar in this Computational Toolkit series. Thank you for the introduction, Idil. So my name is Charlotte and I'm a second year Hetsys student at the University of Warwick. So in this seminar, I'm going to be giving a brief introduction to Jupyter Notebooks in part 1 and also Google Colabs in part 2. So to get us started, here is a brief overview of the topics I will be covering in this seminar for part 1. The overall aim of this talk is to give you an overview of how to install Jupyter, how to create your first notebook, and also a basic overview of the controls, what a kernel is, and some advanced features of Jupyter Notebooks. As this is only a brief introduction, I possibly can't cover everything that you can possibly do with these notebooks. So I've also included some links below and more detailed overviews and advanced features. So that brings us to our first topic. What actually is a Jupyter Notebook? Jupyter Notebooks can be considered as a document where you can write either plain text and also execute computer code. These notebooks are based in your web browser and you don't actually require internet access to use them, they are just contained in a web browser. In these notebooks, you can use a variety of different programming languages, over 100 is included. The most common ones used are Python, Java, R, Julia, MATLAB, and many more. So moving on to installation of Jupyter Notebooks. One of the easiest ways is through the Anaconda distribution. This is a free open source software which can be either installed on Windows, Macs, or Linux. Jupyter Notebooks is not also the only component of this software, as it contains a variety of inbuilt packages such as SciPy, MATLAB, and TensorFlow, and other machine learning models. For information on installation, it can be found on this website, also linked. As well as just providing Jupyter Notebooks, it also provides other software such as Spider, which is also another Python interface, which is very popular amongst data analysts. And it also, for Windows users who may have to install this separately, it also contains its own command terminal, which is very useful as well when you're coding as well. If you only want Jupyter Notebook on its own, you can also have that option through Jupyter Lab. However, in order to install this, you would need access to a terminal, as it is done through a terminal command. More information can just be found on the Jupyter Lab website. So now that we have dealt with the installation process, we can now get around to starting our first notebook. If you had downloaded Anaconda, to open the Jupyter Notebook, first open Anaconda and then click on this icon shown in the blue circle here. It will immediately pop up a web browser which contains the dashboard for the Jupyter Notebook. However, if you're just using a terminal, it's as simple as opening a terminal and typing in Jupyter Notebook in the command prompt and clicking enter. They will both yield the exact same thing. So after you've done that, that'll take you to the Jupyter Notebook dashboard. Now it will open in a web browser, and this will contain all the directories you have in your computer, and you can navigate them as you would normally. So if you wanted to go to a certain file, you could just click documents for etc. and just use it as you would normally on your computer. In this section, you can also create new folders as well, and it will also apply to your computer as well. So everything is connected in that way. So one other important aspect of the dashboard is also the running tab, which is located next to the files tab. This tab essentially tells you all of the terminals and all of the notebooks you're already running, and also gives you the option to shut them down if needed. So for this notebook, we are only looking at creating Python notebooks, which is easily done by clicking the new button as circled here, and then clicking the Python 3 notebook. You can also create a terminal, which is shown by the bottom as terminal, and also a folder or text file through this option as well. Upon clicking that, this will also open a new tab which contains your first notebook, which should look something like the top image. The first thing you may want to do is rename your notebook. The name of the notebook you are working on can be found at the top next to the Jupyter logo. So in this example, the notebook is called Untitled. You can change this by clicking the Untitled and then typing in the new file name in the command prompt there. Once you've done this, if you go back to the command prompt, if you go back to the dashboard in the other tab, you'll also find that the file has appeared under the different name, but also with on the end .ipynb. Any files with this last few section of the name is a Jupyter notebook, so it's easily identifiable by that. So now after we have created our first Jupyter notebook and also renamed it, we are ready to start filling it up. One thing to introduce is Jupyter Cells. These cells are placeholders for code, text, or anything else. In this example, I have just typed in some simple Python code, which should just print hello world. So cells containing code do not automatically run on their own, or after you finish typing in it, you do have to execute the code through the run button located in the toolbar. This is shown by the blue circle on the left. You can also change the type of cell you want to create through the drop bar as located by the cell on the right, the circle on the right. You have a couple of options with this. The default type of cell created is a code cell, but you also have 3 others, which I will explain to you next. So one of the options is we have a header type of cell. These cells are text cells, which, as the word suggests, form a header for your document. There are 4 different sizes of headers, and they are created using different number of hash keys in the second cell, as shown in the second cell, sorry. When you run this cell, you will get the cell below, which illustrates the sizes of these headers. So these are good if you want to sort of format your document or anything like that. So then we go on to the next type of cell, which is called raw NB convert. This isn't a very commonly used cell typically, as it has a very specific purpose, but it's essentially used to render different code formats into either HTML or LaTeX. So these obviously cells are only used when you want to convert the whole document into other, or just a single cell into other formats. This is done using the command nbconvert, which we will come on to in the advanced section. Now we will look into what a Markdown cell is. Most likely you will use this cell as equal as amount as the other code cells. In these cells you can format text, headings and equations, and as shown in the previous examples, I'm going to show the cell without being run and also being run. So what I have here is a few examples of how to format text and include equations in the cells. This includes making the text bold, italic, strike through. It also includes numbering and bullet points, and also an example of how to put in equations into a cell. Now the equations do have to be typed in LaTeX format, however there are a lot of websites online which can do this for you automatically, so it is a really good and clean way in order to present equations in a document. So one of the main features is the toolbar run up above, which is what you'll use the most when using your Jupyter notebook. This is where you can find the main buttons needed to run and use your notebook. So for 1, you have Save Your Notebook. 2, you can add cells below the current cell. The 3rd one is Delete Cells. 4 is Copy or Paste selected cells. 5 is you can move the cells either up or below the cells above it or below it. And then the next few are you can run one cell in particular, you can stop the whole code or kernel, you can also restart the kernel or run all cells. So as you may have just realised, I just mentioned something which is probably quite unfamiliar, and that is the object of a kernel. To put simply, a kernel is a program that runs the user's code or cell. It can be used throughout. It can be also thought of as a computational engine which executes the code in a cell. Depending on the programming language you're using depends on the type of kernel you're using. So in this case, as we're using Python, the default one is IPython. Controlling the kernel can be done using the 4 icons circled below. Or you can typically also use the dropbar named kernel. So these become important to know if you want to restart your kernel, if it's crashed in any way. But please note, restarting your kernel, you will lose all the variables that you may have created and results but that can be, mitigated by just running through all the cells again. So now that I've introduced the basics of the Jupyter Notebooks, I wanted to illustrate some examples of how some people have used Jupyter Notebooks. So one way they're used is as a great learning tool. Many people often make themselves lecture notes or learning materials due to their interactive nature. You can easily edit snippets of code and run them. You can have loads of images and graphs, which is really good, and they're formatted in such a way where it easily fits in the document. And also you can also format these to be extracted into like a PDF or a HTML, so they're very, very accessible to a lot of people as well. So now I'm going to cover one advanced feature of Jupyter Notebooks, and that is converting your notebook into a different format. This is done through the NB convert, which I mentioned earlier. It is simple to do and is done in the command terminal. One prerequisite before being able to use it is you must install XZ-LaTeX on your computer, which installation instructions can be found in one of the descriptions links. So in this example, I've just opened a terminal. I wanted to convert the first script that we made previously into a PDF. So I've done this by writing in the command as shown in the first line. Note, I'm also writing this in the same directory which that file is located, and the resulting PDF will also be saved in that directory as well. So when successful, you will just get this little additional information, but then you will have the PDF, which I'll show in the next slide. So the resulting PDF is shown here. I didn't have to do any formatting, that is just how it comes. So as you can see one cell where it says print hello world, and then also the resulting outcome of that. Obviously, when you get more cells and graphs or anything, or text, those will be formatted just the same as that as well. So that's the first part over and done with. Now I'm going to move on to the second part of this seminar today, which is introducing Google Colabs. So Google Colabs is very similar to Jupyter Notebooks in its use and format, so I'll be giving a brief overview into the main differences between the two today. So a brief overview of this section features what is Google Colabs, the main features of Google Colabs, creating and starting your very first notebook, any additional features of Google Colabs which may not be present in Jupyter Notebooks, and also examples of how people have used notebooks. It is worth mentioning that there is no installation process to this software. It's completely online web-based, but the only prerequisite to using Google Colabs is that you're required to have a Google account, which is free to make and offers loads of different access to other things such as Google Drive, Google Docs, and of course emails. So what is Google Colabs? As previously mentioned, it is very similar to what Jupyter Notebook is in that it's an environment for you to run code along with text and document. If you know how to use Jupyter Notebook, using Google Colab should come easy to you and be quite intuitive. As mentioned earlier, it does not require any installation as it's completely contained in the cloud, and you can run it either offline or online as well. You can create and edit them just as you would any Google Doc, and they are contained in your Google Drive rather than your computer. One of the main differences between Google Colabs and Jupyter Notebooks is the collaboration aspect. As this notebook is linked with Google Drive, it is increasingly easier for multiple people to collaborate on a notebook at any one time, making it a great option for collaboration work. It also supports many machine learning libraries. So the main features of Google Colabs, this is essentially the same as previously said for Jupyter Notebooks in that you can write and execute code in Python and also write text along with that, create documentation and format text, and also supports the writing of mathematical equations. One difference, as previously said, is the ease of collaboration with both Google Drive and now also GitHub. You can also integrate libraries such as PyTorch, TensorFlow, and Keras easily. So, starting your first notebook. First, you'll need to log in and access your Google account and also have access to your Google Drive. You can then type the following URL shown below into your browser, or simply just search it through Google, which will take you to the relevant pages. Once you have done that, a new tab in your browser will be created, which will direct you to the Google Colab dashboard as shown in the image. To create a new image, to create a new notebook, all you have to do is click the notebook icon as shown in the blue circle illustrated here. When you have done this, you'll once again have opened a new tab, and this will take you to a page like this. So this is your Google Colab notebook. As you can probably tell, it has a very similar setup and format as Jupyter Notebooks, apart from a few small differences which I'll illustrate now. So one of the first differences is how to run the cell. As shown previously, I have added some simple Python code, the same as before, into the cell imaged here. In order to run this snippet of code, I need to click the button circled in blue to the left of the cell when I finished writing the code. And this will output the following as shown below, which is just below it. The first cell of your notebook may take slightly longer than you expect to run, as it is just setting up the kernel and initializing everything. One other nice feature about this output is that to the left of the cell, you also have a little illustration of how long that cell took to run. In this case, it was 0 seconds, which just means that it was just very, very quick and probably just not worth even noting down. This is useful as it allows you to identify snippets of code which take too long to run, and also potential bottlenecks in your code, which obviously can reduce efficiency of your overall code as well. Also shown in the bottom image is how to add either a code cell or text cell. This is done by either hovering over the bottom of one of the cells, where you get the option of either adding code or adding a text cell, or can be done by using the insert drop-down bar, which also contains these options. So now I'm going to include how to format text in Markdown cells. This is all done through the text cell, and in order to edit the Markdown content, you type whatever you want to include in the left-hand column. So in this case, I've sort of done the same examples as before, such as bold, italics, and also an equation, and also strike through. And then on the right-hand column, this will give you a preview of it being run. So that is the preview, so you can check sort of if your equations are correct or if it's doing what you want it to do. In order to run these, you can either just click enter or just click the little button there, which is the pencil icon as shown in the blue circle there. So also included in this Markdown cell is various other editing tools located in the toolbar at the top of the cell. In order of the icons as shown in the circle, you can toggle the header height, make your text bold or italic, add in formatted code snippets, so it will come out as a quotation and be clearly seen as something different from the main text. You can insert web links, images, indent your text, add numbered or bulleted lists, add a horizontal line, or finally reposition the Markdown preview box column to the bottom rather than to the side. So these are all things you can do with Jupyter. However, it probably is a bit easier for a user who maybe isn't familiar with the certain commands of how to do it in Jupyter to do it this way, as there are just clear buttons for them to use it. So now we move on to the cell toolbar, which is located at the top right of the cell. As shown in the Jupyter Notebook summary section of this seminar, you may recognize some of the icons and what they do. You have your standard move the cell either up or below the other cells, delete a cell, and also the standard copy, cut, and select cells through the More Options buttons. However, there are a few additions with Google Colabs as well. One is to link the cell, which creates a web link to this cell specifically if you wanted to share a bit of code with someone else, but not the full script itself. You can also add comments to a cell, so if you wanted to comment on somebody else's code, this gives you the option to do that without disturbing or writing anything in that cell. You can also open editor settings and also mirror the selected cell in the tab. This produces the cell in a tab to the right of the notebook on the same page. So this is good for if you have a really long document and you want to reference something, but you want to save yourself scrolling back and forth. There are also two other useful features which I want to illustrate in Google Colabs as well. One is you not only have the option to save the notebook to Google Drive, you also have the option to save it directly to GitHub. You will obviously need a GitHub account and allow access from Google, but this can save a lot of time in updating and saving your notebook to your GitHub repository. So this can be done using by clicking the file drop bar. The next ability and really good feature of Google Colabs is the ability to share your notebook with other people. So this can be done either by clicking the share icon highlighted by the blue circle at the top of the notebook, which allows you to share your notebook either through an email address or through a shareable link. So when you also share this, you also have the option to, can the other users edit or comment or just view the code? So you have a lot of control in what other people are able to do. So now that we have covered the basics of Google Colabs, I just wanted to once again share some examples of how people have used these notebooks. It's very similar to how people have used Jupyter notebooks, and it shows the flexibility and all the things you can do with them in data analysis, illustrations of data results and things such as that. So thank you all for listening, and I hope you have learned and enjoyed listening to this seminar. Any links mentioned and further information will be located in the description below. And if you have any questions, please feel free to contact me at the email there or refer to the Hetsys Outreach Toolkit pages as also linked there.